Good morning. My name's Rowbottom. I'm a principal engineer at Lutron. I'm going to be talking today about dynamic lighting control. It's going to be all a learning exercise. It's not going to be any product specific or manufacturer specific. So if there's any of those questions, we'll do them after the presentation. What we're going to talk about is the levels of dynamic lighting control for different applications. We're going to develop a narrative on, or a sequence of operation, how the space might be used with dynamic lighting control. I mean, we're all used to switching and dimming today, and that's pretty easy. But now when you're going to be changing color as well as intensity, it gets a little bit more complicated. We're going to evaluate the light quality of dynamic luminaires. A lot of fixture people have jumped on this bandwagon, and there's quite a bit of crap out there that you got to filter out. And then we're going to talk about the different protocols that are being used. So if we're all good, I'm going to start. So what is dynamic lighting? So we're used to switching, we're used to dimming, and it's not really any of those. It starts with warm dimming. So this is what we've done traditionally with incandescent light sources. So when you have the incandescent at full, it's like a whitish light. As you dim down, it goes more orange, more red. That's warm dim. Now we're coming up to tunable white. This is changing the correlated color temperature of the fixture to match the application. So I can vary both intensity and color temperature for different effects. And we'll talk about where you might use those. And then full color changing. This is, we've seen this in the past with DMX control. Anybody who's been to Vegas, you'll see like in all the hotels, the red, green, blue, and they make all the, the sequences of color and stuff like that. This is now becoming a little bit more mainstream using, different technologies. So this is what I'm calling dynamic light. So how do you know if you need to include this in a project? You've got to ask a bunch of questions. The first question, is there ever a desire to mimic daylight? So, you're in Florida right now. I don't know if you've ever been to the beach here at sunrise, but the color of the sun is a bright orange ball in the sky as it comes up over the horizon. It's not very intense. As it moves up, it gets more intense and the color changes from red to orange to whitish to a bluish white, and then in the afternoon, it goes through a similar sequence and sets in the west. So do I ever want to do that inside a building? You may have heard of things, circadian rhythm, circadian cycle. These are all things that people are trying to do to bring daylight into a building. Will there ever be a desire to use color? Maybe color for, changing the appearance or the mood of the the appearance of the environment, or marking things like meeting room occupied, purple, meeting room available, green, whatever. Will there ever be a concern about interior design changes? I build this room, I paint the walls beige, which is essentially a warm color. I change them to black. Do I need something different? Or I change them to red. Do I need to change the color of the lighting? Is there some sort of product or artwork or rotating visual, elements that require different different dynamic lighting? So what level of this lighting is required? I told you the three things, the warm, the tunable white, and the full spectrum. When do I use each one? Well, if there's ever an activity that needs dim light associated with the desire for warm and relaxing environment, dining rooms, kitchen areas, places like that, maybe the ideal solution is warm dim. Now with LED, all the warm dim is built into the fixture, whether it's a screw-in or fixture based, it's all inside the fixture. So I basically tell it to go to a certain light level, and the manufacturer at that light level programs the color temperature. I can't change that. The only way I change it is by changing intensity. It's built in by the manufacturer. So that's something that you want to review in person. I want to see this lamp. I want to see its effect as I dim down. Is there a desire to incorporate theatrical or dramatic color changes based on events or seasons? So these fixtures tend to have a red. This is the CIE color space. These are all the colors that we can see. On the outside edge is the monochromatic colors, the reds, the greens, the blue. Inside is a mixture of different colors. So if I had a fixture that had a green LED, a blue LED, a red LED, and a white LED, this is the black body curve, I can essentially drive the fixture to anywhere inside that triangle with, if I choose, high quality white light. So, this is a color changing solution. And then lastly, all other applications fall into the tunable white. So do I need to change the mood with dimming? Wall. Spectrum is full color spectrum or tunable white. And this is typically how it's done with tunable white. There's typically two LEDs or two LED arrays in the fixture, one at a cool color temperature, one at a warm color temperature, and you just change the ratio of intensity of each. How you change that intensity is a bit of a trick, but in theory, you just drive one more than the other and you can get, anywhere along that straight line. So what I'm going to do is go through like a case study of not a simple application, of an application, and I'm going to choose a healthcare patient room because it's got some sequence of operation that might be complex, and you can understand the kind of things that you need to ask for every installation. So here's the project. They're going to have tunable white light, and they're going to have a color changing light at the end of the bed area here. And it's kind of, typically that's a distraction light for the patient to play around with and make all the colors of the rainbow and stuff like that. All the other lights are going to try and simulate a circadian rhythm style application. So this is the reflected ceiling plan. So we've got a headboard light, we've got exam lights, down lights, here's the color changing light, and then here's a vanity light. And those are the different zones that we're going to be controlling. So how do you get started? The very, very first thing you have to do is you have to interview the end users. How do you want to use the space? Like a lot of engineers sit in their office and dream up the sequence of operation based on code and stuff like that. This is going to be different. This is now really personal. I'm going to be changing the color as well as the intensity. So I need to get involved with the end user, whether it's the staff who are going to be manning the room, the facility operator, or even people in the physical space. So I need to know what tasks and uses for each space. I don't know anything about a hospital room, so I got to talk to them. How do you use this room? What goes on in the room? What are the different things that you might want to do? Come to mind. An emergency. Well, what do I do with the lights in an emergency? The patient wants to take a nap. What are we allowing them to do? I mean, do I come in and can I override that nap light and things like that? So you develop scenarios that define the different experiences after you've interviewed the end user. And then the other question that a lot of people forget is like, is this scenario the same in the middle of the night or is it different? Is the day a different sequence? Night completely different. So then, you consider both user personas and key individual users, and you start to visualize the scenarios and consider what the transitions might be. How do I go from a nighttime to a daytime mode? How do I go from an emergency back to regular lighting? Is the fade times involved? What does the color do during fade times? And then, you write your narrative up, which sequence we know as a sequence of operation, and review it with the user. I interviewed you guys. This is the what I think we discussed. Is this correct? Is there anything we need to change? And then, don't forget on the construction documents, we need that detailed narrative of each scenario. And we also need to know what the keypads are going to do. A lot of these spaces are going to have controls in them. I mean, when you leave, go and have a look at this control on the wall. A certain company that I work for supplied it, but the people in here never labeled it. No one knows how it's used, and that's not a good scenario. So you really want to put in the documents, what are the labels that go on these keypads so that everybody agrees to and everybody knows how they work? So a critical note, customized user experience, that's this, or sequence of operation must be space and user dependent. If I try and use this on maybe I'm just going to make this up, on a maternity room, maybe it's different than what it is in this patient room. So let's have a look at the daily cycle that we agreed to. So what is normal is the color, temperature, intensity will change in an attempt to mimic what's happening outside. Red, deep red, low intensity, orange, higher intensity, much higher intensity, going towards the bluish colors, and then in the afternoon changing back again. During changing, the fade time will be long to minimize distractions. You don't want to have, yes? Not really. I mean, I hear what you're asking, but it gets too complicated. And then things like, the next question is, shall I change it if it's a cloudy day outside? Well, I probably don't want a cloudy day inside. So, you're going to have to come up with some compromise. Or you could change it. I mean, these things are all changeable in the field. But I would not do it. It gets too complicated. You can do it from an astronomic time clock and start the trigger point. So lights fade, from the most recent time clock event when returning from a daily cycle. So say there's an emergency, and during that emergency, the lights decided, that later, if the emergency wasn't in place, they would go to a different intensity and a different color temperature. I want to catch up to that event and fade to it. Yes? Oh, it's literally unlimited. But in our experience, maybe 20 transitions is all you really need. I mean, we're going to be ramping from one to the other. So they're going to be going through like a slushing thing where it's going from one level to the next. So the whole thing is actually dynamically changing all the time. So it's not step functions. No. You'll build large fade times in to go from one transition to the next. Early in the morning, it's going to be faster. And then from about 10 o'clock till 3, it's going to be pretty fixed. And then from 3, it's going to be big steps. And then you get, 5 or 6 o'clock, and then they're going to compress. So it's a curve like this. So these are the different scenarios. In the morning, the lights are going to come on to low intensity at a warm color temperature or a low CCT. And then as the day transitions, they're going to get brighter and they're going to change to a bluish. In the afternoon, like 6 o'clock, they'll start to diminish. And, at 10 o'clock, we'll choose a endpoint color temperature and intensity that we maintain throughout the night if the lights are going to stay on. So these are the different colors. What value should I use? Do you really want a red accent? Or, should you start off in the warm tones, go through neutral? Here's cool, an overcast sky, and then this blue accent energized light is ideal for 10 till 4 or 5 o'clock. So here's a check on the patient scenario. So between 6 and 10, we're going to set the lights at medium and follow the color, the CCT cycle. And then from 10 till 6, we're going to have the lights low and following the daily cycle. Any override lasts for 15 minutes. So this is just a quick check-in. So, the lights are at some low level or off. The staff comes in, checks on the patient. 15 minutes later, they go off. If it's at night, it's just a different color, a lower intensity. Here's a much more comprehensive exam. So in this exam, the lights are going to be set at medium light level, and the lights over the bed are set to bright. The keypad is disabled, and it's going to last for an hour. So they come in, do their stuff, and then when the staff release it, then it goes off. And then this is a nap situation where the patient has control over the lights themselves, and they have a keypad, that turns all the lights off, and the same keypad raises and lowers just the headboard light. So, different scenarios depending on what the patient's doing. So, what happens if the patient has a late night procedure? Do you want the lights on full? I mean, maybe that's a different case. Or the family comes in, the patient's awake and reading, but the patient would like to take a nap. What do you do with the lights? The patient needs to go to the restroom, or the patient, we didn't even talk about the color tuning fixture. And then what about shades? If there's any motorized shades, how do they fit in? In an emergency, do I want the shades down? During the day, hopefully I want them up. And you can see these other scenarios. So there's other spaces, think of other spaces. In an office, who should have control over the color temperature of the lights? So a quick poll, who likes the color temperature in here? Who hates the color temperature in here? I mean, people have different opinions about lighting, just like, we were talking HVAC before. Is it too cold in here? Is it too warm? Who's God? Who has control over that thermostat or that light control? Should there be personal control of the recessed lighting? This kind of lighting, which we use for general lighting. What do you do about workers that stay late? Can they bring it up to 100%, 50%? Can they change the color? It goes on and on. What about a school? Should there be similar lighting conditions for exams, no matter the time of the day? In my opinion, I would have an energized light during that exam. So that would be in the cool spectrum of light at high intensity. Give the kids plenty of the circadian stimulus and keep them awake. What level of control over color temperature should the teacher have? Is the teacher educated to know that warm may not be ideal for a learning environment? That's more relaxed kind of lighting. And then again, where the shades fit into this thing. because that's still light. So anyway, we've visualized all the scenarios. These are the zones that we had in the space. So this is the family zone. This is the over the bed exam zone. This is the headboard, the color tuning. This is the general lighting, and then this is the lighting for the sink and the restroom. So what controls would I use for this space? Well, we said we want to give the patient the ability on their control to turn everything off, and then number one controls just the headboard. Then the patient gets another control, number two, that controls the light, oops, oh, my laser just went. Controls the lighting for the tunable, the full spectrum fixture over here, and off, so I can change color. And then the guests get a control that just control their own fixture on or off. And then there's other controls. What about the restroom? What about the vanity? And then the critical control is the control for the staff to come in. You know, I'm going to do a check on the patient. That was that scenario that we described of 15 minutes. There's going to be a exam, an emergency where the lights are all locked out, and then, you know, and all off. Those are all wall-mounted controls. Yeah, it looks like it's something you hold in your hand, but it's designed to go in a designer opening with a wall plate on it. Yeah. So, you know, now you have to write it and document it. So in the drawings, it would be, you know, on whatever keypad between 6 a.m. and 10 and 10 and this is the narrative, so that everybody knows how this thing is going to work. It's a lot of work, but you're doing double the lighting now. You're changing the color along with the intensity, and it gets complicated. If the commissioning engineer gets to the site and there's none of this narrative, they're going to program it something probably that the customer doesn't want. So let's talk about the quality of light. I showed you a picture of this thing. This is the color space. In the space is a line. It's like a frowny face. That line is the black body curve. That represents the different colors of white. So if you mix green, red, and blue, you get some sort of color of white. And depending where you are on here, it's either reddish, orange, yellow, white, towards the bluish. Those are the color temperatures. The more blue, we call that cool white. The more red, we call it warm white. And it's all specified in Kelvin, degrees Kelvin. So on the curve are other subcurves. This is U prime and V prime. These are the coordinates of the graph. And if I change the U and V by 0.01 in this direction, I go from white light to I start to get into the purple range. If I go on the other side, I start to get into the green range. Why is this important? Well, it depends on the color tuned fixture. If you do I'm going to show you a little demonstration right now. I just have to change this thing over to something on my computer. So if I bring up this white barrel that you can see in front of you, I can bring the light. Is it working? So it's gone up to full. Can you press button number 3, please, on the right-hand side? The third one down. Perfect. So you can see this is I've got it at full intensity. I can come in, and this has 2 strips of LEDs in. It has a warm strip, or I can drive it to a cool strip. So I can change the intensity of the fixture. And by manipulating the intensity of the different LEDs, I can go anywhere between the bluish white, and the reddish white. So I can go down to warm, or I can go all the way up to cool, and anywhere in between. If I run a quick demo, and someone was asking me about what are the timestamps, you can see this demo is going through a daily cycle, and keep looking at the time, and you can see how many steps we built into this one. So, 9 o'clock now, it's its coolest temperature. It's probably getting close to max intensity. As the day progresses, not really much change until you get into the early afternoon, and then you'll see this thing slowly start to ramp down. So we're now at, it depends where you are as well. If you're up north, it's different, especially in the winter. So we get in late afternoon, and it's probably lower in intensity and changing in color. I mean, all of these are programmable to, whatever installation you're at. And this is, you need to work with the customer. What do you want this to do? Define the sequence of operations. So I'm just going to stop that, and I'm just going to leave it where it is. Could you press the second button, please? So the whole point of what I just showed you was to talk about this slide. So if I'd have chose in this fixture 2 LED strips that were very, very far apart in color temperature. So say I chose I'm just going to make this up, a 10,000 Kelvin strip and a 2,000 Kelvin strip. The only place I can go is a straight line between those two things. I can't map the black body curve. So as I start to decrease the cool white value and ramp up the warm white value, I'm going to be going eventually into a purple region. The light's going to look purple at that point. Now, if I chose my fixture a little bit more intelligently, maybe I don't need 10,000 Kelvin and 2,000 Kelvin. I need 3,000 and 5,000. What it would do, it would mean that my curve, the line I go on follows more closely the black body curve, and you wouldn't drop into that region of purple. The same is true on the other side of the curve. The manufacturer, for whatever reason, might have built the LEDs here and here. Then I'm going to go a curve up above the curve. I'll be in the green section. The ideal would be to use a red, green, blue, and white fixture with feedback that actually maps the curve. That way you would get, the light that you really desire. But you may not need it. It may be okay to go in. This might be okay, or this might be okay. It depends on the application. So here's an example. So I've got the 2 rooms. Here's the range, the 2,700 and the 6,500. What does it look like at all the color temperatures? So here's a picture at 4,000 Kelvin, and it looks a bit different until you plot in what the 2,700 and the 6,500 is, and now you can see the purple tinge because I dropped below the line. How do you fix this? Different bounds, or you use full spectrum lighting control. So, let's summarize some of this. How do you eliminate poor performance in these fixtures? There's things on here you've probably never seen. You're going to validate that the source color matches across all fixture types. I buy this fixture from one manufacturer, I buy the other fixture from somebody else. Do you think they're going to match? Probably not. You got to see it. It's now I want to see it with my eyeballs. What is the color fidelity? There's a new way of measuring, of representing color. We're all used to CRI, the color rendering index, which is a palette of 14 colors, and it's how well those colors are visualized with compared to an incandescent or a light source like the sun. So if I have it's sort of equivalent to CRI is color fidelity. If I have something better than 80, that would be good, but 80 is still pretty poor. Color vibrancy. So does my fixture desaturate in some colors? What about the red? We really like red, but for some reason in the old CRI measurement, we didn't even include red in the color palette that we typically represent. We only do the first 8 colors, and the 9th one happens to be red because, LED was pretty crappy at red for a long time. It's now quite good at it. What about flicker? So there's a measure, this PST, basically, if the value is 1, 50% of the population can see the light flickering. So you want this fixture, whatever driver they put in, to have a PST of less than 1. And then there's something called stroboscopic visibility measure. Again, 1 is just visible. So if you ended up with a fixture that was great, greater than 1, somewhere on the order of 1.6, it's probably poor performance. You've never asked for these before, I doubt. So here's some recommended measures. Similar LED modules when choosing fixtures. That will give you the better color matches. Consider modules that actually feed back. So in an LED module, if it's a full spectrum, will be a red, a green, and a blue, and hopefully a white to give you nice quality white. How do you know that the red, green, and blue and white are at the right values? Well, some fixtures put feedback elements in, little receivers that measure the light coming out and the color coming out, and can alter the internally to the fixture, alter the ratios to give you what you programmed it to be at. You probably want a color fidelity of greater than 85, and in a lot of applications, you want to saturate the red colors. We like red. Red looks better to us. So if the red is overdriven beyond the normal value of 100%, it's going to make things pop. And then you want to have the flicker, certainly less than 0.7. Oh, I must be out of range. I missed one. So you got to get it from the OEM. These guys want to be big boys now. They don't want to just switch the light on and off. They now want to do color mixing. These are some of the things I need to do it right. None of them are going to give you this. It's going to be like pulling teeth. Other design considerations. Who's an electrical engineer? Anybody? What is the most common method here in the United States to control dimmable fixtures, control-wise? 0 to 10. This is not appropriate for this type of lighting control. The reason I tell you that, it's an analog method of control that is not defined by any standard of what the dimming level needs to be in between the 1 and 10 volts. It is also susceptible to long distance run, voltage drop, and electrical interference. However, the fixture people are going to push this because this is what they push for dimming. So here's the problem. Every fixture in this scenario has at least two control wires, one for intensity and one for color temperature. This one has hue and intensity, so that's the different colors and the intensity. So that has two. So in our scenario, we've got 14 runs of 0 to 10 volt wiring. We've got to keep it separate from the power wiring because of interference, and we've got to land the power wiring in the fixtures. This is like mission impossible for a lot of electricians. So, this is, you're going to end up with bundles of cables and trying to fix it. There's something called DMX. This is a DMX 512, where you can have 512 addresses on a link. Each address can be intensity, color temperature, or hue and intensity. The only problem with this is if you run the loop room to room to room, if you max it out, you can't make any changes in the future. There's another one that came out of Europe called DALI Type 6. So this is just sending a digital address, 64 fixtures on a loop. And in this scenario, each fixture has two addresses, one for color temperature, one for intensity. Again, if you max the loop out, you can't make any changes later on. There is a new one in Europe called DALI Type 8, and that's specifically to address tunable white fixtures. So it has basically one address, but two parameters that is passed to that fixture, one of intensity and one for color temperature. And then there's, everybody's went on the holy grail of wireless, and there really isn't any common protocols for color. So, there's a limited number of these things, and, some of them, the number of zones, depending on, how many hubs or receivers you have on the system. So here's what I keep talking about. This is what the fixture guys want to sell you. So they want to put two strips in there, or two LED pucks. They want one at cool, one at warm. In this scenario, I've overdriven the cool, I've lowered the warm. The resultant output would be cool in temperature. At what intensity, I have no idea. So they want you to put in cool intensity and warm intensity. So I got a quick math question to ask you. I'm going to make it easy. I've got a 5,000 Kelvin strip in here that can give me, I don't know, 100%. I've got a warm strip in here at 1,000 Kelvin that can give me 100%. So my two extremes are 1,000 and 5,000. I want this fixture to run at 4,000 Kelvin at 30% intensity. What intensity do I set the cool at, and what intensity do I set the warm at? You guys are smart. Come on, give me the number. You know it. You're all shy, right? It's almost, well, it is impossible to do this. This is one of those things where you've got two controls and you do this kind of thing. Oh, crap, I've gone beyond. And then you lower, oh, now it's the wrong color. And you do this for about 10 minutes and you get some value. It is not practical to use in the real world. On paper, it looks like I can do it, but commission it, I can't do it. I can't program scenes. I can't do daylight control. I can't do time clock fade rates because I don't know what it's going to fade to between two points. It looks easy, but don't use it. If you don't believe me, try it. This is what you'll end up with. The customer will expect some control on the wall that's marked in certain color temperatures at certain intensities. You're going to spend days trying to program that room. And then you're going to go into the next room and it's going to be different because the surfaces are different, the fixtures are different, and you're going to have to start again. You won't be able to do daylight control. Like, how would daylight control work with a tunable light fixture? What would you control? You could do his scenario. You could use the daylight sensor to control the color temperature, and then we'd match exactly, and we would do completely dynamic lighting. There would be no steps in that scenario, or we could change the intensity, or both. You can't do it with what I just showed you. Time clock is very difficult because when a time function takes place, there is a transition from one level to the next. Now, your transition, so say I set the cool at 50% for my example, and the warm at 20%, and that somehow magically made the right color. Well, one's at 50, one's at 20. All I want to do is lower the whole light output by 10%. Well, what do? Do I lower it? I can't lower it by 5% each because one's at 20 and one's at 50. So if I lower what? I mean, you can't do it. And this is what you end up with. You end up trying to calibrate the thing in the room. Here's what most people are going towards right now. It's giving you, just like I have up here, intensity and color temperature. And then within the fixture, there is a color mixing chip that has the lookup table. Oh, they want 3000 Kelvin at 42%. It runs the calculation and turns the cool on and the warm on to the right values. That is how you do white tuning. So in the spec sheet, it better say intensity and color temperature are the two control inputs. They often leave that gem out because they are promoting that. So basically, how do I control the color? How do I control the intensity? Are they independent of each other is the question. So you can do all of these things. Here's where it gets a little bit tricky for specifiers. You got to hold the specification. The electrical contractor is going to come in and do the usual with the owner. I can do the same thing, so I can save you all of this money, and they are going to come in with this. So if they do, you may want to put a clause in the specification that they program it, right? But this is what you want to stick with if you can. So, have you heard of circadian stimulus or melanoptic lux? This is basically the amount of light and spectral value that basically stimulates our circadian rhythm. It takes us out of our sleep pattern, and it stops the production of melatonin. And for circadian stimulus, the number is 0.3, right? So a lot of designers, especially if you're doing like a well building, you know, the well building standard, they're going to ask for this circadian stimulus. So the lighting designer is going to simulate this. And what they do is the standard calls out for it at the eye level. So the calculation is going to be at your eye level looking towards the wall. Unfortunately, they use grayscales as the finishes of the surface. So you're going to set the light at 6000 Kelvin at 80%, and we're going to see what light level, what circadian stimulus, or equivalent melanoptic lux we get. And it looks like we maxed out over the 0.3. So this is great. It's going to stop the production of melatonin. It's going to stimulate us, and everything's great. We get into the room and we take the actual measurement and we go, oh, what's happened? The light level seems to have gone up, but the circadian stimulus doesn't meet our requirements. That's because in most real rooms, the surface materials absorb the bluish lights and reflect the warmer lights. So even though I've got my light at 6,000 Kelvin overhead, the walls are going to absorb some of the blue and reflect the warmer colors back to us. And circadian stimulus is spectral and intensity. So now I've changed the spectrum in that room, the stimulus has gone down. So, it may look when I actually measure it that I'm at 4,500 Kelvin. How do I fix this? You just have to build a buffer into the lighting calculation. So instead of, if I max my fixture out 100% to get this CS of 0.3, I'd be screwed. So what I do is I design the lighting so that the value of the intensity at the color temperature is less than the maximum of the fixture. So in this example, we calculated the fixture needs to be at 6,000 Kelvin at 80%. And what we actually do is we bring the light level up in intensity. We keep the color the same. We bring the intensity up to give us our circadian stimulus. But if the fixture had been maxed out 100, we couldn't have done that. So you got to put buffers in these. It's kind of counterintuitive in the age of energy saving and cutting it right to the edge. But now we're playing around with color. So a summary of the design and setup. Use digital protocols. 0 to 10 is not really going to work. It's going to be too much control wiring and the problems are going to manifest. That color space that I showed you, along the black body curve, there's little ellipses normally drawn on it, and these are called macadam ellipses, and they're longer in the color of white. One macadam ellipse, the population cannot see a difference. However, the ellipse is much narrower in the color direction. What that means is we easily see differences in color. So any voltage drop along a 0 to 10 volt wire may not be noticeable in intensity, but it sure is going to be noticeable in color. So just be aware. I mean, I don't say don't do it, because you will do it, but when you do it, you'll have problems that you can't fix. If you use digital, it future-proofs your design. I can always change the zoning. Whereas 0 to 10, you're going to have to do the wiring. And make sure you include enough addresses to future-proof. If I have to add something or change something, maybe new fixtures will come out with 4 addresses and do really crazy stuff. Use drivers with intensity and correlated color temperature input. This gives the better flexibility and the better chance that you're going to meet the sequence of operation that you worked out with the customer. And then provide intensity buffers when designing for circadian metrics. So if any of you do well building design, it is one of the measurements that they're going to look for in a room, and you need a buffer on intensity to bring the CS up to the value that you need because of absorption on walls, furniture, etc., etc. So consider all the stakeholders when you're doing a tunable white. In the past, it's just like, I'm going to follow code. I'll do daylighting during the day. I'll turn the lights off when nobody's in the room. Time clock sweep after 6 o'clock, done, right? Now this is a personal thing. What do you want the lights to do? Do you want, 100 steps in the circadian cycle during the day? Or is 10 okay for what you're going to do? Do I want a daylight sensor so I bring the daylight inside? So don't forget to do the transitions. And then when you get to schematic design, if you use this digital protocol, you're going to, minimize changes in the system moving forward or during the design phase. And you really want to be evaluating the color accuracy, consistency, and quality of the fixtures. This is, you want to sell me this fixture? You want this fixture on my job? Give me a sample. I want to see it. How does it work? Understand the different protocols and how they affect the control wiring, and then include, detailed control narratives. And then finally, during the installation and commissioning, if the contractor is providing the value engineered option, you're going to have to stick to the spec and say, this is not going to meet the customer's sequence of operation. If you want to supply this, you meet the requirements. And then expect the color temperature to be different at eye level than at the luminaire level because of the absorption of materials. So, takeaway, designers need to hold the spec. It's a lot of work, and the person who's working with the owner to cut the cost doesn't really care. Well, thank you. Thanks for your time.